Hey guys, welcome back to my shop. If you've seen my last video, then you saw me repair this Jones and Shipman 540 surface grinder. Did an oil repair with the oil tank and some oil repairs and a good cleaning, and then it was operating again and it looks to be fine. But if I tested it, then I was not happy with the surface finish. And you can see there's some vibration on the finish here. And I've tried different wheels, I've tried different balancing, dressing the sides, dressing and then balancing, dressing it again with different wheels, with different balancing systems, and yeah, the results stayed the same. So it was not in the wheel. I checked the spindle for runout. It's making a little bit more noise than I would like to be, but I don't think the problem is from the spindle, and the runout is very good. But then I noticed that the machine itself did have some vibration, and yeah, it's coming somewhere. So with the flat belt system on the back, then maybe it's somewhere in the motor, so we need to check the pulleys and check for runout and see if there's a problem on there. So yeah, I was hoping this machine was done, but I guess the adventure continues. So let's get back to work and let's get back to the machine and yeah, see where the vibration is coming from. So I pulled the machine off the wall to have a little bit better look on the back and on the pulley system. So here you can see the pulley in the back. It's mounted with the same nut as the spindle uses and also with the same thread on the OD. So I will probably can use the wheel hub puller to pull this one off. But first then because I want to check the runout, I need to get the belt off. And I will need to get down there to do that. So it's a little bit dirty and got some oil on the inside. There you can see the column height adjustment thread, and here you can see the pulley from the motor. This is the oiler for the column thread that should be able to remove. Just move it up a little bit and then it was free to go. On the wheel here on the bottom, or this hub, pulley, is this a hub or a pulley? You guys tell me. And there was also a suggestion from the guys from England I sent an email to, asking about the belt system and possible for vibrations. They said the old belt can delaminate a little bit and leave some on the pulley, and you will probably see that the pulley is quite dirty, not only on the inside but also here on the outside and over here. So I will clean that and then have a look at the runout. For the future me, belt tension right now, I can just easily press it with my pinky to the wall. The other thing that I noticed is the motor is on rubber mounts, because you can see that the bottom hub is moving up and down. So to loosen the belt, there are these bolts, also two down there. Loosen that. Loosen the nut over there, and then pulling the motor up. And there you have the belt. Alrighty, so this is the belt that is on mine. It doesn't look too bad. But this wheel hub is, and you can also see it's moving up and down a bit, so I don't think that's good. Let's clean it and check for runout. It's a little bit difficult to get in there with the camera. This is the spindle hub and switched indicators, and it's about 500, so 0.05 millimeters. I would say not the best, not the worst, but I don't think that this will cause any vibrations. But what I'm not too happy about, and I hope you guys can hear it, I think the spindle makes a little bit more noise than I would normally think it should be, with only two bearings in it. But yeah, I don't have experience with these machines, so I'm not sure what should be normal. But first let's check the belt drive pulley on the motor side. Alright, this is clearly too much. 0.6 millimeters of runout, and I think that's a good indication. When you can see that it's moving, then it's clearly too much. But damn, that means I have to pull the motor. That means the motor cars out in front have to remove all hydraulics and all electrical system. At least that's what I understood if I was reading about it on the internet. But it has to be done. So just keep moving. Can just barely fit this puller in there, but it does work. And there you have it. It seems like it's even balanced, but with 0.6 millimeters of runout, I don't think that helps. The question is, what causes the runout, or what made it? Did the shaft of the motor bend, or is it worn down different, but also this outside ring was also moving quite a lot, and the inside, so I don't think it's wear, and that makes me wonder. It was also a nice press fit on the shaft, so it looks like the shaft is moving, and I wonder how that was possible. You can see the shaft is moving up and down. Not good, guys, not good. 0.4 millimeters at least run out, so that's too much, and I need to fix that. So let's pull the motor. And there you have the motor. So let's try to get it out. Don't drop it. And there is my little friend. Oh boy. I got it out all in one piece. So the motor is mounted on these rubber dampers. I think I will need to replace these as well. The bearings look fine, but the spindle has run out, and it should be precision balanced. Not this one. So the motor is clean, not making too strange noises. Okay, now I can definitely feel some play in there. So the bearings are gone and need to be replaced. Let's check the other side. And there you have it. and there's this ring on here that I also need to pull off, but I can't reach it with this tool. Damn. Yeah. Still in one piece. Or did I just bend these two? Can't imagine that happened. We'll watch the slow-mo. So I have the shaft between the centers, and it has about 0.1 millimeters runout where the bearing was. Let's check on the other side, just make sure. 0.01 millimeters runout, but that's on the center, so I don't expect much there. 0.12 millimeters runout over here, so I can imagine that that will cause also some vibrations. And strange thing is that these two are bent, and I don't think that should be the case. So now I have it on the center and centered on the steady rest, and I have to push it, but it has the same, almost the same runout as I measured on the machine. It's almost 0.4 millimeters. We'll zoom in a little bit on the indicator. So here it's 0, 0.1, 0.2, 0.3, 0.35, and then it runs back again. So we'll measure it a little bit closer on the shaft and see if it actually gets less and if it's bent or not. Okay. Same reading, or same positions, a little bit less reading, but still a lot of movement. So it's definitely bent, but before this point, let's get in there a little bit closer. And even close to the steady rest, it has some run out. Can I check it on the steady rest itself? Because that should be 0. I got the tip in between the fingers of the steady rest, and as you can see, it's almost 0 now. So from bearing to bearing it's good, but the end of the shaft is bent, so that will be an interesting thing to fix, and I may have to get the torch or the welder out